Hi, I'm Cry Bachman from Building on BIM, and in September 2022, I presented at Autodesk University. I've got 19650 problems, but the BIM ain't one. So I thought I'd do a quick little capture of the presentation here so that you can see what this presentation is about. In this presentation, I'm going to quickly talk a bit about ISO 19650 standard, and then we're going to look at how it's potentially unlocking digital innovation within digital twins and smart buildings. So let's jump into the presentation now. I'm going to start out with a little bit of an introduction. For those who don't know me, I'm Cry Bachman. My day job is working as leader of digital innovation at the design practice Dialogue. You might say, well, what does a leader of digital innovation do? Well, I focus on the emerging tech side of our industry. I look at researching and implementing new technologies within our design practice so that we can keep practicing on the leading edge. And as part of that, I work closely with our client groups who are, also advancing and putting together things like digital requirements on their projects. Now, I do work as part of our practice-wide technology team, but I did actually start in design. I've been working for 19 years in the industry, 11 of which have been in Canada, 8 in the UK. And some of you might also, if you've seen me at Autodesk University, I have also previously presented shared coordinates because after all these years, I still don't get it. But today we're going to be talking about some more innovative and sort of forward-thinking stuff when it comes to the BIM standards as well as digital twins. The practice that I work with is Dialogue. We're an integrated practice, quite large, primarily based out of Canada, but we do have a couple of locations in the United States. And we're a fully integrated design practice. And this is important when we start getting into talking about digital twins because it's important to understand that we see things holistically. We see projects from not just the design perspective of an architect, but also from the engineering perspective and that sort of large scale master planning, everything all under one roof. And this will become key as we kind of get it more into digital twins because, well, integration is kind of a key word. So why did I present on the topic? Well, because Dialogue has clients that are looking at creating digital twins for their projects or they're looking at smart campuses and smart buildings. And as you'll see, there's a lot of crossover between the two. As well as part of that, we use the ISO 19650 standard on some of our projects. And this is a standard that's developed internationally and is growing in adoption. And it's also getting a lot more recognition within Canada, where I'm primarily based out of. And part of this is the reason that I get into the standard is because I spent a lot of time in the UK working with BIM Level 2, which was the ISO standard's predecessor. And if you're interested in this talk, it's probably because you've heard the keywords ISO 19650, digital twins. So let's see, as we jump into it, how all of this digital innovation comes about. So as part of this talk, I'm going to cover off four key sections. Now, a lot of these topics I could go into much deeper dives, much bigger presentations on, but in the short amount of time that I've got for an Autodesk University talk, I'm going to cover off four sort of aspects of it. I'm going to give my take on the ISO standard, try to sort of give some of the points that I think are more important to focus on. We're going to examine some of those key concepts of the ISO 19650 standard, but try to bring them back to kind of plain English language, trying to get away from the technical terms and really understand what they're about. Speaking of terms, BIM, digital twin, it kind of gets a little bit confusing. What are these different terms and where's the crossover? How do they compare? So we're going to do a quick little comparison of them to understand, and then we're going to bring it all together to understand how the ISO standard is applied to BIM and digital twins. So quickly to get to know the ISO standard. Again, my take on it. First of all, it's based on BIM Level 2. So a lot of people got started getting attention to this. What is this BIM Level 2 out of the UK? But it's a UK standard. It's not really for us. Now, the BIM Level 2 was released in the UK, yes, as a UK standard, and it was released as a publicly available specification, which means it was released into the wild. People started using it in jobs. It wasn't really tested and tried until many years later. And now that it's gone through that rigor, we're now starting to, it's now being transformed into the ISO standard so that it can be used internationally, globally, and nobody's sitting there going, oh, that's a UK standard, that doesn't apply to us. Now, speaking of which, As an international standard, you might be saying, but how does that apply to me in my region? So keep an eye out that there are regional annexes that are being developed. I know, for example, the one in Canada that's being developed that will also augment the international standard to sort of say, well, how does this apply to us specifically in the terms we use and the processes we go through in our country or region. As well, you'll hear me refer to it sometimes as an ISO standards or ISO standard. It gets a little bit back and forth, and that's because part 1 through 5, there are multiple pieces of the standard. So there are standards. And some of them are still even in development as the time of this recording. But the biggest thing that I really want to emphasize with the ISO standard is that I see it as a framework. Now, what does that mean? Well, a lot of people, when it comes to the standard in our industry, they think of like layering standards and things like that. Oh, what do I have to call my files, or what do I have to, what color do I have to make my layers? And this isn't a very prescriptive standard in that sense. There are elements of it that are prescriptive, but there are also lots of blanks. Think of it this way. It's sort of a framework that it tells you the steps you have to go through, but it doesn't tell you what you have to do specifically in that step. It's just telling you the emphasis, and you need to do this step for a specific reason. So for example, it says that you need to use a classification system, but it doesn't say which classification system to use. It does have some standards when it comes to the terms and the sort of process that are sort of key to remembering about it. And the other piece about this to really remember is that it's trying to think of things a bit more holistically. Clients, or the appointing party as they describe it in here, is a key contributor to this standard and sort of making it successful. So one of the key things about this is that you can't just apply this standard by saying, I want an ISO 19650 project, because one of the first things that it's going to do is ask you as the appointing party or the client to define what it is you're looking for. So a lot of people, when it came to BIM level 2, ran into the same problem where they sort of said, I want a BIM level 2 job, but they didn't define anything further. This is not that sort of thing because there's so many blanks that you have to fill in. So let's talk about some of those key concepts. So when it comes to BIM, a lot of people traditionally, as they've been getting into BIM, are still using it as a design tool or as pre-construction or coordination on site and things like that. Or maybe they've even gone into facilities management, but each of these groups is looking at it separately. And the only person that is looking at this thing holistically is the client themselves of the project. Now, you might sort of say, well, isn't the client the one that's using it in the end? Well, in some cases, we've worked with clients that have actually been outsourcing their facilities management. So in theory, each of the different smaller groups could be operating completely independently. And the only person that has the vested interest in the whole thing is the client. So how does the client actually get what they want? They have to define their requirements. And what's key about this is that the requirements need to be defined up front, much in the way that when a client comes to us and says, I need a project built, well, okay, let's define how many square feet is it? Where is it located? What departments are going to go into this? Things like that provide a design brief. Well, if you want digital deliverables, they have to be defined up front. And this is a key thing that is needed, because as we move more to digital deliverables, it has to be recognized that this is still a deliverable and that it still needs to be defined up front. So how do we go about that? Well, when it comes to defining that information, as a design consultancy, we deliver information. So we can deliver, for example, exports of spreadsheet information, we can export schedules, we can provide the 3D models. And so when we have the conversations with clients, we say, well, do you want this information? Or they say, can I have this information? And when we say, yes, what information do you want? They say, well, what information can I get? And that's not really the right attitude for this. What needs to be done on a client side or the appointing party needs to be seen as, well, okay, if you want information delivered, you have to identify what information does your organization need to be delivered. Now, when it comes to BIM, a lot of people think of, well, just 3D models and stuff, but there's a whole other aspect of asset management and the information that is exchanged through people's hands as part of the design and construction process. and how that information can be leveraged later on as part of the actual asset management and running of a facility. And so the question isn't just what information needs to be delivered, it's what does the organization need to manage that asset, to manage that facility, to run it. What is it? Data that you're going to be putting into a building automation system? Is it floor plans? Is it images? Is it reality capture? What is it that you need to feed into that process? Because basically what they need to build up in order to run a facility is the information that they need to maintain that asset. And so basically the question of does the organization manage the asset will define what information does the organization need to be delivered, which will turn into what needs to be delivered, which will be transferred into it actually being run. And so that might start to sound a bit clearer, but there's even a step higher than that, because it's not just about what do you want to do to run that specific facility, because imagine a group that runs a portfolio of properties or a campus or the federal government, for example, that has a whole slew of different facilities that they have to organize. All of this is needed at an organizational level, and it needs to start at that top level, and it needs to be driven by business drivers. And so there's this question of what does your organization want to achieve across all of its assets and projects? How does it want the projects to be run in order to and that will dictate the information that you need to gather. So as an example at this level, you might say, well, we want the goal of our facilities to be run with predictive maintenance, and therefore we want them to be run more efficiently. We want things not to break down on a regular basis. We've got business goals of running more efficiently. Well, that will mean that implementing a building automation system that can do things like fault detection and can, detect problems before they do predictive maintenance. Therefore, you're probably going to be requesting specific information to be transferred into those systems as part of the construction and design. Things such as gathering all the model numbers, serial numbers, warranty information, and getting all that information inputted as part of the building automation system and part of the delivery of the project. And so all of that information can kind of flow through, and you can see it's driven by a business driver at that high end. Now, specifically, that's fine for kind of your portfolio properties, but what about the specific project? So there's also a need to identify project-specific goals, because each project may be different and there may be certain things that you need to achieve on certain projects that are very unique. As an example, there may be certain things like because of a certain site's adjacency to a neighboring property, there may be additional information that needs to be delivered in order to feed into the process and make key decisions along the way. So all of these different steps are part of the ISO standard. And so as I've sort of said at the beginning, I don't really want to get into the acronyms and kind of focusing on them. These are things that you can Google and look up on your own, but understand that each of these red sort of highlighted information requirements and the information models are what the ISO standard does and defines. But what's key about this is understanding why they're important. Why is that step needed? Why, as a client group, do you want to have those information requirements up front and driven from the top level down? This sort of helps in the examples that are given again and again of, for example, you don't want to be asking for things like COBie deliverables, which is a massive amount of information out in spreadsheets, if there's no business driver behind it. It'll just add cost to your projects and doesn't necessarily help anyone along the way. So if we think about them, it's about starting at that high-level organizational strategy, specifying what is needed for each system. That will define the exact information that is required, along with any sort of drivers for the specific project, which will then therefore turn into the model that is actually delivered as part of the design and construction, which can be incorporated into a model that is needed for running the facilities. And this is all done up front. And it's important to understand, well, wait a second, we've worked on projects where people have said, we want BIM, and then we start doing BIM, but then they say, well, can we get this out of it? And then we were like, well, you didn't ask for that up front, so it'll be an extra, and then the client's unhappy. Well, that's the problem, is traditionally BIM hasn't necessarily had all these digital deliverables defined up front. This is part of what the ISO standard is actually trying to achieve, is it says you have to issue these documents as part of the RFP going out to different bidders. So if somebody is bidding to design your building or to construct it, they need to know about this information up front and to have it as part of the RFP. There's another key step to this, which is then those groups bidding on the job provide high-level delivery plans that tell you how they're going to deliver against those requirements and which steps they are and are not going to do. Now, that information allows clients to evaluate all the different bids and compare them apples to apples. Is this group over here using a database system for collecting the information so that it's much more efficiently collected and it's validated? Or are they just going to be exporting stuff out and manually filling it in spreadsheets? This is the sort of thing that you need to know up front. Is this group doing clash detection? Is this one not? Then you can actually compare who's bidding on the job and who's doing what BIM processes, so that when the contract is actually awarded, it's done on the purpose or on the premise of understanding exactly which group is doing what. Then, now you might say all that is a lot of information to include up front, but then the information is detailed. So that high-level strategy is defined up front and sets the game plan. But then if the contract is awarded, then it gets into defining what the actual detailed delivery is going to look like, who's going to do what when, and including all the information from subconsultants and subtrades feeding into it. So again, as part of the ISO standard, these are defined as things such as a pre-appointment BIM execution plan, right? If you start going into the terms, it gets a little bit confusing, but if you understand the philosophy of what they're trying to achieve with the ISO standard, it makes a lot more sense. So how does this happen as it flows down? So you've got the requirements being issued, you've got them made as part of the contract, you're now actually designing and constructing the building. So you've got a BIM model and it's growing, or as they like to call it, a project information model. And it's growing in information. Now, the information is now going to be issued to the appointing party or to the client. So what's important to understand about this is because that EIR was issued as part of the contract, we now have something that we can evaluate it against. We now have some way of saying, yes, this is the information that is being delivered. Can we validate it against something? Do we know if it meets the brief? Yes or no? And if it doesn't, it gets rejected and it has to be redone. If it's accepted because it actually meets the requirements and you have something to evaluate it against, then it can be incorporated into the asset information model. Now you might sort of say, doesn't that happen at the end of the project? Well, it depends. There are terms such as soft landings, the idea that you're slowly building up that information over time in an asset information model. There might also be the need to deliver certain key pieces of information to the client at different stages throughout the project, so to ensure that they actually have that information to make a key decision at different stages of a project. So this is something that will actually occur again and again as the project progresses. Now you might sort of say, well, hold on a second. Yes, okay, we deliver those files against the EIR, and we've done that before. We know that we're issuing an LOD 300 model. What about all this information? Well, see, that's where level of detail fails. Everybody likes the term LOD because it's easy to go to a spreadsheet and say, this is a 100, 200, 300 model. But then everyone starts to get into this weird zone of, well, yeah, but for facilities management, how do you define it? That's an LOD 500, isn't it? It's supposed to be a super detailed model with lots of nuts and bolts and stuff. No, clients don't actually want all that information in a building automation system. They don't need it for running their facilities. But then how do you define it? Well, that's where LODs fail. And this is where something that the industry is trying to fix now, which is we've traditionally just defined an LOD and a model element author and called it a day, which is fine for 3D geometry, but it lacks level of information and it's not asset management focused. And to give you a sense of what I'm talking about here, and from our experience, level of information need, or LOIN, but at the same time you're not supposed to make it into an acronym, is probably one of the hardest things to really wrap your head around, because we're starting to define things at a completely different level. As an example, The ISO 19650 standard just defines that you need to define the level of information need. So the clients have to have a way of defining that information that they need from the different delivery teams. Now, there's other standards that go on to explain how this could be done. And as an example, EN 17412 Part 1 actually goes beyond that and starts to look at, well, how do you define things on the level of geometry? How do you define them for data operations and facilities management? What are the manuals that need and documents that are needed? So as an example, you might sort of say, well, wait a second, what do you mean geometry? That's just LOD, right? No, because you might have how accurate is it? Is its location correct? Is there a visualization that's being produced? Do they want to do VR fly-throughs, in which case they're going to need to know proper finishes on different appearance, so the appearance of things. What is the alphanumeric information? What sort of identification and information do they need to run it? And this starts to get into a lot more. Like, as an example, let's just compare a few different assets that we could look at. Think about the way that a facilities management group might look at an interior door versus an air handling unit versus a pump. Well, first of all, the level of detail might be slightly different. Its reliability of exactly where is it built might be needed at different levels. You might also, and then when you get into the parameters that they might track within a facilities management system, are completely different. So you've got things, for example, on a door, you might need only 4 parameters, but on an air handling unit, you've got a whole list of them, and the ones that are on another maintainable asset like a pump are completely different again. So, and this goes beyond that. Even when you get into things such as like the individual units, an air handling unit might have a whole set of parameters, but for each stage, there are going to be different things that are needed. Maybe early on in the process that you actually, within schematic design and design development, you actually need to know that the model type, but you don't necessarily need to know the model number or serial numbers, because that information comes as once it's actually built out on the site. And think about it this way, you're dealing with data. So if any of you have ever dealt with situations where you have to be very prescriptive with databases as to what type of information you're inputting, there could be situations where each of these parameters, you also need to know what type of field is it. Is it a number, string, date? How many characters can you have in that string? So we've done situations where in order to understand that, we've actually had to define each of those parameters for each of those different fields. And it also has to be known, how are they collecting that information? Is this being directly inputted into a database that's accessible by everyone? Is it going to be exported as some sort of format and then imported? Are we going to be collecting it in a different system? So you start to see that there is a need for a change. And unfortunately, Excel just ain't going to cut it. I mean, you probably could do it, but you're going to struggle. So what you have to keep in mind is that there's almost a need within our industry to start looking at databases. And this can be just about managing the information, let alone actually collecting the information separately. I mean, you might sort of say, well, obviously a database is going to be needed for collecting the information, but there's examples out there. So for example, this one is the UK BIM framework, where they put together an Airtable, or sort of an online database system, that just defines the requirements and allows it to filter for different groups, so different groups can see their requirements separately. There's other services out there that are paid, like Plannerly, that allow you to create the documentation for managing it all on an online resource, so that, again, it's centrally located, so that everybody has access to those requirements as they change. You've got things like Derofis that are databases that overlay on top of Revit databases, because Revit and the databases within them can't actually hold all of this information. Now, a lot of people will also say, but wait a second, what about COBie? Wasn't COBie supposed to be the answer for all this stuff? COBie also, in our experience, does have certain fields that are standard, but then when you actually talk to facilities management groups, there's certain fields that are beyond what is in COBie that they want to be able to track. So it's not necessarily an end-all be-all for what you need. So we've been talking a lot about BIM for facilities management, how it transfers over. So what about the evolution of this? When we start talking about BIM into building automation systems, what about digital twins? And digital twins is something that's come up because traditionally, if you talk to facilities management groups, a lot of them are working with systems that aren't graphical. They don't use 3D models. They might use some floor plans that have been exported or created initially in CAD programs. But a lot of the information they're looking for is metadata. It's the stuff about the parameters, about the key pieces, and then they're going to be tying in some feedback from the actual operation of the facility. So they haven't necessarily used a graphical model up until now. But it begs the question of why not? Buildings are 3D. Wouldn't this help? And this starts to lead towards a new term within our industry, and that is digital twins. And I just want to explain quickly the vision behind it, as I understand it. And which is, there's a lot of different ways you can apply a digital twin when it comes to manufacturing processes or aviation and all sorts of other things like that. But let's just talk about buildings for a second. An owner of a building really has a problem, which is that buildings are complex. They are, collections of disconnected systems, the people that use them, the environment that they're within, and none of that information talks to each other traditionally. So as a client or an owner, trying to understand anything and everything that's happening within a facility to be able to optimize it and be able to service it better and do things with it, well, it's hard. You don't really understand how it runs and how it's being used. So could we actually understand that? Could we gather all the information about monitoring and understanding what it's doing right now? Could we look at the past and could we predict the future? If we've got an understanding of what's happening in the building, maybe we can do that. And can we understand that from anywhere? Access that information? And can we understand it spatially? Because buildings are spatial. And so it starts to look at a digital twin. And so the digital twin stack is basically that you start with a real world building. Okay? We all know that. But we have a virtual copy of it. And this is where you'll see the fancy graphics of digital versions of what's out there in the real world. But it really you need a digital 3D model of what's out there in the real world. And it doesn't have to be super, super accurate. It's to the level that you need. And BIM actually does this in reverse. We actually do the 3D model and then produce the real thing by going out and constructing it. Now, within that facility, in order to understand what's going on, the systems have to be connected. Internet of Things. You need to be able to have connectivity into any sort of equipment. So anything that's facility management run, a maintainable asset, you're going to look at connectivity. So you want to be able to connect into pumps, into fans. You want to be able to any of the lighting equipment. You want to then also put in additional sensors so that you can do things like understand occupancy, for example. And you want to take all that information and you want to bring it into a system that then you can start to make a connection between the 3D model and the information. So there's a relationship. It's not separate data, it's actually connected. And we're going to look at connecting all of that information in an online or accessible database where you can track the past and monitor the present. Why? Because you want to be able to apply analysis, you want to be able to do simulation and automation, and eventually, hopefully, predict the future with all of this. So it's about creating a data stack. And you'll see that the spatial data becomes part of this. You've also got the asset data of things like, so you've got the 3D geometry, you've got the asset information of warranty information and serial numbers, stuff that's static. Then you've got the live data coming from all the different sensors and live IoT devices. You've got occupancy data, so you understand how people are using the facility. You've got maybe the climate information. Is it raining outside today or not? What's the temperature outside? And you create all that in a stack that then allows you, and it's about integration of data so that you can apply then analysis, simulation, and automation on top of that. And a key thing to understand is BIM is part of this process. It's not something separate. It actually forms the first two steps. Now, a lot of people will hear this and they'll say, wait, this sounds a lot like smart buildings. Wait, what's the difference between smart buildings and digital twins? Well, smart buildings is very similar. And if you haven't seen the stuff by James Dice, he posts on it. He's got a great podcast and he's got a great blog where he sort of has dived into this, and they've got a network of people on the Nexus group that are looking at this. And it's about breaking down those traditional silos. And this is the way that he drew it on his website, where it's about taking all the different devices, forming a network that connects them all, then applying what is referred to as independent data layer on top, and then allowing different applications to plug into that data. And when you start to look at it, you'll see right there in the middle, it says data model and data storage, which is very similar to my diagram that I drew when it comes to digital twins. It's because this is all headed towards the same thing. It's about integration of data. And that data model that he's got drawn in the middle there, well, if it included a 3D model and it was incorporated in as part of the process, effectively you've got a digital twin potentially. So some people might say, well, wait a second, when we're talking about smart buildings, why do we need a 3D model? What's the advantage of it? Well, think about it. For facilities management and operations, if you're not necessarily standing beside the piece of equipment, you don't necessarily know exactly what's around it. You might, as you become more familiar with the building, maybe you do. But if you're running an entire campus and you're located in an operating control room on the other side of the building, you want to be able to understand what's happening. So when Digital Twins tries to bring to the table is that idea of understanding what's happening within the actual facility right around the object that you're getting information from. So for example, Autodesk has now come out with their own platform, Autodesk Tandem, where they feature, being able to click on an object and being able to see the information about that object, the live sensor information, for example, which would allow somebody operating a facility on the other side of the country or the other side of a campus to be able to see that information. So it allows you to understand things much faster. The other thing that's really cool, if you want to see a great vision of this, Howden, Microsoft, and PTC, if you Google that and look at this video online, it's a great little description of, or a great little vision of how we could potentially use a digital twin in the future, which is by putting on a Microsoft HoloLens 2, the unit itself will look at the 3D model and look at the environment that you're around and match the two up. What that allows you to do is walk into, for example, a mechanical room where it then displays over top of the physical objects what it sees in the digital version. So it's going to show you the digital readouts. It's going to show you, is the unit off and on? Is it operating correctly? You could potentially push buttons virtually in front of you and have it interact with the actual physical object. And I think this one little video is a great example that I like to show clients of what potential future there is for digital twins. So, digital twins, this sounds awesome. Long live digital twins, BIM is dead. No, we're not going to call it BIM. We're going to call it digital project delivery. We like to call it project information modeling. Well, the truth of the matter is BIM is not dead. BIM is just part of all of these different processes. So whether you're talking about digital twins, smart buildings, BIM is not necessarily being replaced. It's being incorporated into something bigger. You'll also hear a term out there called digital transformation. This is about breaking down the silos and trying to access the information holistically and being able to do more with it. And this is exactly what we're trying to do. So all of the stuff that we apply to BIM isn't dead. It's actually just evolving. So you might sort of say, well, wait, if we go back to all those information requirements, how does that then unfold when you start talking about digital twins? And that's what I'm going to talk about next, is what happens when you look at the ISO standard, but you're trying to do stuff more than just BIM. And can that lead to innovation? So if we think about, we've got our requirements up front for a BIM project, it's been made contractual, we are producing a BIM model, we now start to produce that information and hand it over because they want it to be incorporated into an asset information model for running the facilities. Well, a digital twin is basically just a layer on top of that. So what's important to understand is that all the same stuff that applies to delivering BIM will still apply once you're starting to work on digital twins. It's just going to be incorporated into something bigger. So what does that look like? Well, if you sort of go back to those information requirements, we were saying, well, what does your organization need to manage your assets? Well, if your assets are being run by digital twins, they don't necessarily you're not necessarily throwing everything out, you're just changing the term. So part of what we've started to ask the question of is how do we use this framework then to actually apply to projects where they want to do something bigger. They want to actually incorporate it and move on to digital twins. And I think the important thing to understand is that the same philosophy of what is behind the ISO standard still applies. You still have the organizational information requirements up front. You're still going to have those high-level project objectives that you're going to need to define, which will then dictate how you run your facility. The difference is you're starting to get into information requirements that will start to expand into new territory. So you're starting to talk about, well, how do we specify equipment that actually needs to have IoT connectivity and can be incorporated into this? Or do we need to install certain additional equipment so that we can get that information about the occupants and the environment? And this doesn't all just come through as drawings and documentation and things in BIM files. Because as much as there's information requirements up front that need to be passed on, there may also be some stuff that's transferred into project level specifications so that it can be actually executed by the construction team. There's also rules of engagement because some of this stuff may not even be developed for years. So for example, this is something that might start small on a particular group and start to grow from there. So as an example, it might be something where we look at, well, we don't actually know which system it's going to be incorporated into yet, or we don't have that system installed yet, but we need to know that there's connectivity. As an example, there's no point in putting in a system that is a closed, proprietary, walled garden. It may run beautifully, but if you can't get access to the data later on to incorporate into your digital twin, it's going to be useless. And so there need to be rules set in place that people understand so that if later on a master systems integrator gets involved or somebody is specifying a particular system, they know which things they need to do and which rules they have to comply with. So again, thinking about this, all of the stuff that's within the ISO standard still applies. We still start with our high-level business goals. When you talk about digital twins, this is the same framework that we use, is that we're trying to, again, not get hung up on the terminology or the fact that the ISO standard talks about BIM, but it's talking about the fact that at an organizational level, you need to start with those business goals and objectives. That will drive down what you actually need to do for how you manage your facilities and what you're trying to do with them, and what you're trying to do on the projects. And that will define the information that you need to gather and incorporate as part of your project. So when we've been looking at this, we've been trying to sort of figure out, well, how do we actually connect all these pieces up? And we did a project process where we did a digital whiteboard and started putting little post-it notes and dropping in different pieces in the bucket. And then we started drawing lines between them. And the important thing about this is that it helped us understand that we needed to drive things from the organizational level down. And we also needed to see the connections between things. Because if there's certain things in here, like somebody asking for COBie deliverables later on as part of the information exchange requirements, well, why are they asking for that? If there's no business driver about it and it's not being incorporated into the asset information model, well, then there's no need for it. So whereas if there's other key pieces that are needed, that can be incorporated. So dropping these different pieces in the buckets, but also making those connections and understanding that it has to be thought of as a long-term goals. So within the client side, if any of you are on that, within the actual owner side, is that it needs to be driven by those business objectives. And so what we see here is we went through the process of dropping different pieces into different buckets. Now, the way that I framed it up here may be something that's completely different than somebody doing in another process. There may be other people that know the ISO standard and go, well, no, you wouldn't put project delivery objectives under the PIR, that goes under the EIR. In our experience, the main thing about this is not to necessarily get hung up on which bucket these are in, but to understand that they are part of the process. And as long as they're communicated to the appropriate parties, then it's good. And so we sort of want to put out that caveat. It's not necessarily where they go as much as are they there and are they connected back at the right level. So for example, the other question that has come up is whether or not an OIR should actually be issued as part of the project. If you're running a public institution like a university, maybe you want to have that made publicly available so that people can understand the business goals that are driving the digital change in that process. Federal governments may want to have that publicly available, but a private real estate group may not actually want those publicly available or even released to the project teams. So whether or not they're released is one thing, but the important thing for clients to understand is that they need to have them in order to be able to justify why they're asking for specific information. So maybe the EIR is the only thing that's actually issued to the consultants, so they have something to measure their delivery against, but at least they know in the process that if they ask the question, yes, there is a business driver behind it. So we come to the end, what next? Well, for starters, if you're not as familiar, if there's a lot of stuff here with the ISO 19650 standard and you're going, that's a lot of terms. This is stuff that I would say it takes time. It's going to take time to learn and digest. And if you're just getting into the ISO standard, you don't necessarily need to know everything all at once, but it's going to take time. But my emphasis on this, focus less on the terms and more on what the philosophy and the meaning behind these things, because you'll be able to implement them much faster once you understand that. Once you understand that the OIR and what its purpose is, it's less about the term and asking for it and having conversations about whether or not we should call it an OIR, and more about understanding, yes, we need this because we need to have those business goals. And clients need to have that expertise in-house to be able to be part of that conversation. This is more than just a 30-minute class. This is something that needs, time to digest. The industry is changing. There is huge potential of what digital twins and smart buildings can do for our built environment. There's huge opportunities for zero carbon, for efficiency, for financial benefits within projects, for even feedback into the design loop. There's huge potential, but it's also a big undertaking. So for all those groups that are looking at this, this is something that you need to consider, and you need to kind of consider what are those first steps you need to get into. But I would emphasize for any client groups that are listening to this, start with that organizational level, because the best success that we've had with groups that we've worked with is starting with those high level objectives of what are they trying to achieve. Gain that in-house expertise. Go to your consultants and talk to them, but in time, begin to kind of pull that information and get more people on board. It is something that I think in our experience, the vast majority of people as of 2022, there are certain groups and certain projects that are pulling ahead that they understand this and they are implementing on projects because they know what is needed. But the vast majority of groups are just getting there now. So also keep in mind that there's plenty of consulting opportunities if that's the sort of thing that you're trying to get into. So in conclusion, BIM, digital twins, smart buildings, where is it all? It all gets kind of foggy. The truth of the matter is that there's no clear borders because it's about integration. It's about bringing the different data sets together and incorporating them together. And BIM is still part of that. It's just becoming a sub-part of it. So rather than chucking the term out the window because it's been around for 20 years, we should be thinking about how it incorporates into the bigger side of things. Integration is the key here. And the industry is still evolving. There's a lot of people using these terms in different ways, and sometimes it gets very confusing. But that's why we like the ISO standard, is that it provides a framework for having that conversation around. The tools and the terms can help guide that along and have those conversations with clients. Sometimes we don't even refer to the actual OIRs, EIRs, and AIRs. We just talk to our clients about what are your high-level objectives with this stuff. And we use the ISO standard as a framework for having that conversation. The other thing about it is that standards are not perfect. You may look at them and go, I don't really like this, I don't like that. Okay, I get it. But at the same time, using the standard terms can also help add clarity. You have situations where somebody might say, well, these are our business data goals and objectives. And you go, okay, what are you trying to do? Well, it's our organizational information requirements, basically. So why didn't you just call it an OIR? I don't know. People like to kind of come up with their own terms sometimes, but I really think that if our industry actually got around the ISO standard and started to standardize on them, it would actually help us a lot of the time. Now, again, whether or not you want to implement the standard as a whole or just in part, the one thing I would say to all client groups out there is define your digital requirements upfront and make them part of the contract. And it's important to kind of understand, because it is a digital deliverable, it is still a deliverable, it is still something that needs to be evaluated and weighed against, and it can't be left so ambiguous that people are halfway through a project and not really understanding what does BIM mean on this project. Now, if you want additional resources, I'd strongly recommend getting the ISO standard and actually reading it. If you're just getting into it and you want something that's a little bit easier to digest, I also recommend checking out the UK BIM framework, which is on their website. They've got some excellent documents that sort of explain it in a bit more detailed, plain English. On the digital twins and smart building side of things, as I mentioned, James Dice and the Nexus Lab, the blogs and podcasts and the pro group, I definitely recommend checking it out, as it's a great place to learn a bit more about this evolution that's happening on that side and how, smart buildings are kind of coming across and becoming digital twins. If you're interested in sort of understanding that side of things, of the sort of property technology side of things, and you're new to this, I definitely check out the Realcomm group and their webinars, as well as the Digital Twin Consortium or Consortium, because they are basically trying to help define what is a digital twin and get everyone to understand it in a simple, easy to understand, singular definition. Autodesk is a member of them as well. So if you're using Autodesk products, they are trying to help with that sort of definition. So with that, I hope this has sort of provided some clarity and guidance and you've gotten something good out of this. Feel free to leave your comments below, and I hope you enjoyed the video.